Hello everyone, welcome back to our channel. In this video, we're going to solve the K-Map POS problems from 2 variables up to 5 variables. Let's get into the video. Before getting into the problems, let us understand some of the definitions. The first definition is about the max term. In POS, we know that we need to AND all the sum terms that are present in the expression of the POS. If in that expressions, if all the sum terms having all the variables of the main function, then that term is called as the max term. Here we have the example f of a comma b comma c, which is equal to a plus b plus c plus b dot b plus a plus c. Here the first and last terms are the max terms because the first and last sum terms having all the variables of the functions, that is a, b, c. But the c plus b, the second term, don't have the variable a. So it is not considered as the max term. The second definition is about the canonical POS. The POS expression is called as a canonical POS when and only if all the sum terms are the max terms. Here we have the example f of a comma b comma c equals a plus b plus c dot a plus c plus b dot b plus a plus c. Here all the three sum terms having all the variables that are present in the function. That's why this POS expression is called as the canonical POS expression. Now let's move with the problems. Now let's start with the two variable K-Map POS problems. The problem statement we have is f of a comma b is equal to pi of 0, 2, 3. Here we have two variables. So n is equal to 2. In order to find the number of cells in the K-map, we have the formula 2 power n. So that 2 power n is equal to 2 power 2. So that we are going to get the 4 cells in the K-map. Now here we have the K-map of 4 cells. Here we are considering A as row and B as column. We know that in the POS, the dominant value is 0. So we need to put logic 0 at the positions which are mentioned in the problem statement. Now, as per the problem statement, let us put logic 0 at the cells 0, 2 and 3. And the remaining cells will be filled with logic 1. Now let's move for the grouping. Here we can't able to group all the cells because we don't have 0 at the cell 1. So let's move for 2 cell grouping. Here we can able to consider the cell number 0 and cell number 2 as one group. Then the cell number 2 and cell number 3 as the second group. Here we covered all the logic zeros which are present inside the K-map. So now let's move for naming these groups. Now let us consider the first group. In the first group, we don't have any common between the first and second rows. So we can't able to consider the A value. Now let us consider the column. In column, we have only one column, that is B bar. So that we can able to name this group as B bar. Now let us consider the second group. In the second group, we can't able to see any common between the first and the second column. But in row wise, all the cell values are present in the second row only, so that we can able to name this group as A. Then the final expression will be like f of a comma b is equal to b bar dot a. Now let's move for logical implementation. Here we have the two terms a, b bar which are ANDed together. So we need to consider the AND gate. For the AND gate, we need to take b bar as one input and a as the other input, so that we are going to get the output as b bar dot a. So let's move with the 3 variable K-map POS problem. Here we have the problem statement like f of a comma b comma c is equal to pi of 0, 1, 2, 3, 5. Here we have 3 variables, so that n is equal to 3. As per the formula, 2 power 3 is equal to 8. So we need 8 number of cells in the K-map. Now we have the 8 cell K-map. Here A is considered as row and BC are considered as columns. Now let us fill the logic 0 inside the cells of the K-map with respect to the problem statement. Now let us fill the logic 0 at the cells 0, 1, 2, 3 and 5. The remaining cells will be filled with logic 1. Now let's move for the grouping. Here we can able to consider entire first row as one group so that we can able to have 4 cells in that group. For the second group, we can't able to take the cell number 5 individually. We can take the cell number 1 and cell number 5 together and we can able to make 2 cells in that group. Because we need to group the cells in such a way that the cells must be grouped as large as possible. Now let's name the groups. In the first group, we can't able to see any values at the second row. The entire values are present in the first row itself. So we can able to name the group as A bar. In the second group, all the values are present in the second column only. With respect to the second column, we can able to name the second group as B bar C. Now, the final simplified expression will be like f of a comma b comma c is equal to a bar dot b bar plus c. Now let's move to the logical implementation. The simplified expression, we have two terms. In the second term, we have b bar plus c. So that we need OR gate. For the OR gate, we are taking b bar as one input and c as other input. So that we are going to get b bar plus c as the output from that OR gate. At the end, we need to AND this output of the OR gate with the A bar. So we are considering the AND gate and taking the input as A bar and the output of the previous OR gate. So that we are going to get the final expression as required with respect to the problem statement. Now let's move to the 4 variable K-Map POS problem. For the 4 variable problem, we have the problem statement as f of a comma b comma c comma d is equal to pi of 2 comma 3 comma 4 comma 6 comma 11 comma 12 plus d of 10 comma 13 comma 14. Here d of 10 comma 13 comma 14 is represents the unknown values. Now let's start with filling the logic 0 with respect to the cell positions which are given in the problem statement. Now let's start with filling the logic 0 from logic cell 2. Then logic cell 3, 4, 6, 11, 12. After this, we have the don't care values. We have the don't care values at the cell numbers 10, 13 and 14. Let us fill those. 10, 13, 14. Then fill all the empty cells with logic 1. Now let's move for grouping. Now, as per the cell value that we are seeing in our K-map, we can able to make two groups that each group is going to have 4 cells in them. For the first group, I am considering the cells 4, 6, 12 and 14. And for the second group, I am considering 2, 3, 10 and 11 cells. So, we covered all the logic zeros by including the don't care values also. Here, we left with one don't care value. It's not mandatory to include all the don't care values, but we must include all the logic zeros in the group. Now let's move for naming the groups. Let's move with the first group. We have second and third rows. Between the second and third row, the common value is B. So we are taking B as the common between second and third row with respect to row. And with respect to the column, the common between the first and last column is D bar. So D bar is considered with respect to column. Then we can able to name this group as B plus D bar. And let's move with the second group. For the second group, we have first and last rows. Between this first and last row, we have the common B bar. And with respect to the columns, we have third and fourth column. Between this third and fourth column, we have the common C. So, the group name will become as B bar plus C. Then the final expression is f of a comma b comma c comma d is equal to B bar plus C dot B plus D bar. Now let's move with the logical implementation. At the simplified expression, we can able to see the two terms. Means two sum terms. So we need two OR gates. For the first OR gate, we are taking the input as B bar and the second input as C. So that we are going to get the output from the first OR gate as B bar plus C. For the second OR gate, we are taking the input as B and D bar. So that we are going to get the output from the second OR gate as B plus D bar. As per the final expression, we need to AND the outputs of these two OR gates to get the final expression. So that we need an AND gate. And for this AND gate, we are taking the inputs as the output from the first OR gate and the output from the second OR gate. So that we are going to get the final expression as B bar plus C dot B plus D bar. Now let's move with the 5 variable K-Map POS problems. For the 5 variable K-Map problem, we have the problem statement as f of a, b, c, d, e is equal to pi of 0, 2, 4, 6, 9, 11, 13, 15, 17, 21, 25, 27, 29 and 31. Here we have 5 variables. So that n is equal to 5. So that 2 power 5 is equal to 32. Then we need 32 cells in our K-Map. This is how the K-Map of 32 cells will look like. In the K-Map, we have the center line which represents the mirror line. It means when you fold the K-Map exactly from the center, half of the K-Map will overlap on other half of the K-Map. This will be very helpful when we go for grouping the cells that you are going to see in this problem. Now let's fill the logic 0 at the cells with respect to the problem statement. Let's fill 0 at the logic cell 0, 2, 4, 6, 9, 11, 13, 15, 17, 21, 25, 27, 29 and 31. The remaining empty cells are filled with logic 1. Now it's time for grouping. As per the mirror rule, we can able to group 8 cells here. That are cell number 9, 11, 25, 27 along with the cell number 13, 15, 29 and 31. Because when you fold the K-map from the center, these cells will overlap on each other. So we can able to consider these 8 cells as one group. Now let's move for making the second group. In the first half of the K-map, you can able to see the cell number 0 is opposite to cell number 2 and cell number 6 is opposite to cell number 4. But when you fold the K-map exactly from the center, the cell number 0, cell number 2, cell number 6 and cell number 4 will overlap. So we can able to take these 4 cells as single group. Now the zeros are left only at the cell number 17 and cell number 21. Here we can able to take the cell number 17 and cell number 21 as a single group. Because when we fold the K-map, the cell number 17 is overlaps with the cell number 21. But always we must search for the large number of cells in the group. So we should consider the cell number 25, 17, 29 and 21 for the group. So that we are going to get 4 cells in the group. Finally, we are going to have 3 groups with respect to the K-map we have. Now let's start naming each group. For the first group, we have the values only at the second and third row. Between the second and third row, we have the common B. And with respect to the column, we should consider the second, third, sixth and seventh column. Between these 4 columns, we have E as common. So we can able to name this group as B plus E. Now let's name the third group. In third group, all the values are present between the third and fourth row. Between this third and fourth row, the common is A. Now, with respect to the column, we need to compare the second and seventh column. Between the second and seventh column, the common is D bar and E. So, we can able to name this group as A plus D bar plus E. So, the final simplified expression for the respected question will be like f of a, b, c, d, e equal to a bar plus b bar plus e bar dot b plus e dot a plus d bar plus e. Now let's move with the logical implementation. In the simplified expression, we have 3 sum terms. So we need 3 OR gates. Now for a bar plus b bar plus e bar, let us consider the 3 input OR gate. For this 3 input OR gate, we are giving the input as a bar, B bar and E. So that we are going to get the output as A bar plus B bar plus E bar. Now for the second OR gate, we are giving the inputs as B and E. So that we are going to get B plus E as the output. Now for the third OR gate, we are giving the 3 inputs that are A, D bar and E. So that we are going to get the output as A plus D bar plus E. Finally, we need to give the outputs of these 3 OR gates to the AND gate, so that we are going to get the final expression as A bar plus B bar plus E bar dot B plus E dot A plus D bar plus E. So this is all for this video. If you have any doubts or any suggestions to give, you can give the feedback in the comment section. Let's meet in the next video. Till then, bye.